In today's lesson, we are looking at symmetry of functions, symmetry of graphs, and even versus odd functions. So first, we're looking at symmetry. So if you have symmetry over the x-axis, what that means is that for every xy point, the point x negative y is on the graph. Okay, so if I sketch a quick graph, so I'm going to put a point at 1, 3, 1, -3, let's say -3, 0, and I sketch. So just a quick visual, you can tell that, well, if the x-axis is cutting it in half, it is symmetric about the x-axis. And then specifically, if you look at the point, I have the point 1, 3, and then I also have the point 1, -3. So the x values are the same and the y values are opposite. Makes it symmetric across the x-axis. Now, to do an algebraic test, here's what we do. If we start with the function, let's say we have x equals y squared plus 4. If you plug in a negative y, you should end up back at the original equation. So x equals, I'm going to plug in negative y squared plus 4. So when you're plugging in a negative y, well, negative y squared, squaring a number is always going to go back to positive. So therefore, because this went back to its original after plugging in a negative y, it is symmetric across the x-axis. Okay, so now symmetric across the y-axis. It says, so for every xy, so every point xy, the point negative xy is on the graph. So it's opposite. So x and negative x will both be on the graph, sharing the same y value. So once again, let's sketch a graph. Okay, so I'm going to put points here and here. Let's say here. Let's go over to, we could go 2. Okay, so if I just draw this parabola, as you can tell, this specific parabola, the y-axis cuts it in half. It's symmetric about the y-axis. And if you look at a specific point, so this is the point 2, 2. And over here I have the point 2, negative 2, 2. So the same y value and then negative and positive of the same x value. So similar to the last example, again, here's a different function. If I have y equals negative x squared plus 6. So what I want to do now is test if I plug in a negative x, does it go back to the original equation? So y equals negative, I'm plugging in a negative x squared plus 6. When you square a number, it goes back to positive. Y equals negative x squared plus 6. So plugging in that negative x, you can get it to go back to look like the original equation. Okay, and the last example for symmetry would be symmetric about the origin. So for this one, for every xy, the point negative x negative y is on the graph. So this time, both are negative. So let's sketch a graph. So we'll just do a cubic function. So if I have the point 1, 3, 0, 0, negative 1, negative 3. So I have the point positive 1, positive 3. I also have the point negative 1, negative 3. Okay, so now to do the test. If I have, let's say, x squared plus y squared equals 25. If I plug in a negative x and a negative y, what happens? So I'm squaring both of them. So that means it just goes right back to positive x squared plus y squared equals 25. So that is how you are testing for the different forms of symmetry of functions. Okay, now we are looking at even versus odd functions. So an even function is simply a specific type of symmetry. An even function is simply when a function is symmetric about the y-axis. Okay, and then an odd function is a function that is symmetric with respect to the origin. So we've kind of already talked about how to test for these. With the even function symmetric about the y-axis, that is when we have x, y, and negative x, y both exist on the graph. Just another way to kind of represent that same thing is saying that if I have negative x, if I plug in negative x, it goes back to the original f of x. So that's kind of the test that I was doing earlier in the video, but just kind of another way to mathematically show that. And then odd function, so symmetric about the origin, that's when for every x, y, a negative x, negative y exist. So another way to write that is negative f of x, it is equal to f of negative x is equal to a negative f of x. So if you plug in negative x, result is a negative of that whole function. Okay, so two other examples. So if I have g of x equals x to the fourth plus 2. So let's test if it's an even function. Let's plug in negative x. So what is g of negative x? That would be negative x to the fourth plus 2. And raising something to an even exponent, it goes back to positive x to the fourth plus 2. So plugging in negative x, it ends up equaling back to the original function. Okay, so now odd, symmetric with respect to the origin. Let's look at the function f of x equals x to the third minus 2x. Let's once again plug in a negative x. So I'll have negative x to the third and then minus 2 times negative x. Okay, so this time exponent to an odd, or a variable to an odd exponent, if it's negative, it's going to stay negative. So that's negative x to the third. But here, negative 2 times negative x, that's going to go to plus 2x. Well, let's think about this. If I look back at the original, it's close. If I just factor a negative 1 out, I'll be left with, so x to the third minus 2x. It goes back to the original with simply a negative in front. So it does follow this. You plug in negative x and you end up equaling the original, but with a negative out in front. Okay, so there is the full video on symmetry of graphs and then even and odd functions. Good luck with the lesson.